Hey, believe it or not, I've already did this once and deleted it before I got it on to where I wanted it, so I've got to redo the darn thing. Um, so I don't know. We'll see what color that turns out to be. I have a feeling that's going to be like a changing color, but we know, or we've learned, that schematics are typically in the form, oh, look at that, cosmic colors there. Schematics aren't typically in the form of boxes or rectangles. So on here, I've drew in our first light bulb, drew a resistor and put a circle around it. It's R1, 20 ohms. And then I drew over here the battery. It's a short, it's a long, a short, and a long. And it's 200 volts. And this part over here is what makes it a parallel one, because we're going to add this second branch. All right. Right here, that right there, you wouldn't draw that circle and I just drew, but that right there is what makes it parallel. Because some of the current, let's see if I can get a different color here. Some of the current is going to go down this branch, but some of the current is going to keep going that way. So it's got multiple paths that the current can go. So let's go ahead and start plugging in. First step is to always plug in the given information. And we know that it's 200 volts. We know that resistor 1 is 20 ohms. We know that resistor 2 is 30 ohms. So right now we've filled in this much information. Our second step, all right, what a lot of students do at this point is they say, hey, it's a parallel circuit. Every one of these has to get the same voltage. All right, every one of these gets the same voltage. Each resistor gets the same voltage. Each resistor gets the same voltage. Each resistor gets the same voltage. Yeah, I said it a few times because I wanted you to realize that. So plug it in that way. Each resistor gets the same voltage. So we now know that every one of these gets the same voltage. Well, the other day we learned that when we know 2 of the 3, we can solve for the third. So in this case then, if I want to solve for this current, this I1 and I2, I'm going to take 200 and divide it by 20. Well, what do we get? Hopefully you guys realize we're going to get 10 amps right here. For I2, if we take 200 and divide it by 30, again, we're using V equals IR. Maybe I should have typed that one in here. Let's go ahead and just type that in here just for you guys that maybe aren't quite catching on to why we're doing that here. The voltage is 200, and it's going to equal I times the resistance of 30. Well, in that case, then, we find out that I turns out to be 6.7 amps. Well, let's go back and look at our drawing up here. We said that some of the current was going to go here, and that was 10 amps. Some of the current that's going to go through resistor 2 was 6.7 amps. So how much current did there have to have been before it split? Well, that's as simple as taking the 10 plus the 6.7, and we get 16.7 amps. Again now, people, remember, the only thing we haven't found yet is RT, but we know that V equals IR. We know that the voltage is 200. We just found out that the current is 16.7, and we want to know the resistance. I'll put a little T there. So that means RT has to be equal to 200 divided by 16.7. And that turns out to be then a total of 29.9 ohms. Hey, so that's our first one. Let's take what we just learned and apply it to the second one here. So in this case, I've kind of given you the schematic. We got to draw the schematic, even though it looks almost exactly like this over here on the left. I'm going to draw on our battery. And then it's going to be, there's where the first light bulb is. the second light bulb, and the third light bulb. So now I'm going to put the light bulbs in there. This right here is 12 volts, R1, R2, R3. This is 2 ohm, 3 ohm, and 4 ohm. So there I've drawn the schematic. Next step, plug in what we know. Well, that's 12 volts. Then I'm going to come over here to the resistors. I know that resistor 1 is 2 ohms. I know that resistor 3 is 3 ohms. I know that resistor 4 is 4 ohms. What concept do we know about parallel circuits? Well, this branch is 12 volts. We know that in parallel circuits, every branch, every item, everything is going to get the same voltage. 12 volts, 12 volts, 12 volts, 12 volts. So, $12 volts. There I go. I went through and given each one of them the 12 volts. Remember now, whenever we know 2 of the 3, we can solve for the third. So in this case, it would be 12 divided by 2, or 6 amps. In this case, 12 divided by 3, 12 divided by 3, or 4 amps. And in this last case, it's 12 divided by 4, or 3 amps. And what that tells us then is that we had 6 amps going here, we had 4 amps going here, and 3 amps going here. So how many amps must have been here for this to have gotten 6, this to have gotten 4, and this to have gotten 3? Well, what we do is we just simply add them up. And that means that our total is 13 amps right here. Having said that, now we can find RT by using V equals IR. And we know that 12 equals 13 times RT. So to solve for RT, we're simply going to take 12 divided by 13. 12 divided by 13. And we're going to get an answer then of 0.33 amps. Well, hey, you guys now just have the back page here. Again, draw in the schematic, fill in the given information, find the missing. Draw in the schematic. I know it doesn't say to draw in the schematic. Draw it in, fill in the missing information, and you'll be done with it. Well, hey, I hope that was beneficial for you guys. I'll catch you on the flip side.